Oh, there we go. I think we're live.
We are on the air.
All right, good. Thank you, everyone, for joining. It's still a little bit early, 6:10. So we can start testing your video, audio. Let's see, everything running smooth. Before we start, feel free as well to ask questions. Ken is here, our guest today. Anything you guys want to ask, Java related, Kotlin related, music related, right, Ken?
Hi, this is Jean. If anyone has any questions, please ask them in the chat. We don't have it set up so that everyone can speak, so you're going to put your questions in the chat, and we're going to read them to Ken for you.
Perfect. All right, last.
So we're starting at the bottom of the hour, right? Rodrigo, I can't hear you anymore.
Sorry, that was me. I was trying to mute my own mic, and I muted Rodrigo's mic.
Thank you, Jean.
Very good. So you can only see the screen that I'm sharing, right? You can't see me at the moment?
I can see you too.
You can?
Yes, and you're a little bit of blur, but you can see you.
Really? I put the high def one on. It is toggled high def. But I moved the window to another screen so I can actually see the chat window now. And I can see you.
All right.
I don't know if it's a good idea, but, you know. Oh, and I see the shared window now. I get it.
Yeah.
You know what we also have, by the way? This is, you know, we could go with Google. 15-minute timer.
Good idea.
Okay. It's at the. That's about right, isn't it? I guess it's closer to what?
Yeah.
17?
Yeah.
17.
That's fine. We're gonna be 1 minute early.
I can even do this. How about that?
I'm going to attempt to mute myself again without muting you guys. Rodrigo, can you say something so I know if I'm doing it right?
All right. Sure. If you can still hear me.
I can hear you just fine.
Okay,
yep, you're coming
perfect.
through.
Cool. That means I did it right. I live
All
on a
right.
big street, so I don't want fire engines and such to be part of Ken's presentation.
Okay.
All right. You know, if this was a regular Jug meeting, I'd want to take a picture, you know, of the audience, so something I could tweet or
Exactly.
put in the newsletter. And I don't know what to do in this case. You know, I mean, how can I put in anything, right?
Exactly. I was reading a thread today, Venkat saying that if you used to present standing up, do your virtual meeting standing up.
But Venkat can stand for 10 hours. I can't do that. I can't stand for an hour and a half. I mean, my back won't like that. So, I mean, again, we learn on the tour. You never compare yourself to Venkat on any scale whatsoever, except maybe height. You know, that's about it.
Once we hit 6:30, I can take a picture of the screen, which has the attendee count and stuff, so you have that for your newsletter.
Oh, cool. Okay. Although
That's
I think
awesome.
I can do that too, but, you know, feel free.
But
I mean,
if I do it, you'll be presenting while the picture's being taken.
Oh,
That
even
looks
nicer.
better than taking a picture of yourself taking a picture.
Very good. It's not a selfie. Right. That's very good.
True story.
I mean, the fact we have 60 people, we still have 15 minutes to go. I think that's a good sign.
Yeah, perfect.
We actually have 26 people. 60 is how many people registered so far.
Okay.
But it
I
was
didn't understand
54
that.
people who registered 15 minutes ago, which means people are still registering.
Cool.
Frank
So-
had over 100 on the meetup.
Right.
node.
This is the number of people who registered with the Cloudcast session already. So like people who went early to test their connectivity or whatever.
Okay, I see. There were like more than 100 on the. What's the one we used to register? Eventbrite.
Okay.
About 100.
And they're hearing us now, right? So you have to be careful what we say, right? I mean, it shouldn't be, you know, anything terribly nasty.
No, we should.
No. Is Frank going to join us up here, or is he going to be just out there? I mean, what's the situation with Frank? Do you have any idea?
Frank's going to be joining in quotes out there, like everyone else. It's going to be you, me, and Rodrigo that have voice capabilities.
So I can talk about Frank and he can't reply.
That's right.
Oh, perfect.
See,
Although he can type in the chat box, but that's it, right?
that's it.
Yeah.
Maybe. How is the COVID situation in Connecticut?
We're behind New York, so
Good.
down in the southwest corner, which I usually just consider New York anyway. They've had a pretty major outbreak, but the rest of the state is much pretty far behind that, I guess I'd say. So I guess we have an extra few days. I wouldn't say we have a whole week behind you, but we're a few days behind. Things are not the emergency to the level that you are, at least not where I am right now. And the stores still have stuff. I mean, we're not hurting for that at the moment.
The stores in New York have stuff too. Every once in a while, you have to go twice to get something. Like if you got there right when they ran out of orange juice, you have to wait for another delivery. But it hasn't been bad getting food.
I want to look at Jean's setup. She just posted a link to that. Oh, okay. So that's just somewhat less formal than the rest of us. The rabbit's good though.
Yeah, I have a proper desk that my personal Mac and my personal book writing and all that stuff are on, but I'm not moving it every day. That's a lot of work. So the picture I posted is my work setup.
So that's not the killer rabbit either, is it?
No, just the cute rabbit.
Because you remember what happened to the site called Think Geek got bought by somebody. I think it was like GameStop or something. But when they were still around, I got a pair of killer rabbit slippers for my wife. She loves those. So.
Yeah, no, this is a rabbit that I got as an Easter time gift about 11 years ago. And I put it by my computer because it's now the screen share bunny, which means if the screen share is being slow, I poke it and the screen share gets faster.
Wow.
My team also has a Jira duck. We've had that one since before the crisis, and it was the same deal. Our boss bought us the duck, and we poked the duck because the duck was the animal for the Jira book in O'Reilly, so we went with that.
Oh, I wondered because Jira duck sounds like a good phrase. I wondered where that came from.
Yeah, so he looked up which animal was on the cover, bought us a team duck, and it now attends all our meetings.
Ah, very good.
Do you know anyone else who's written an O'Reilly animal book?
Several people, I think. I have to think through it. The one on my book is what they call a kinkajou, of all things. Yeah, we'll get to that. But I'm trying to think. There's several animal books. Actually, all three of my O'Reilly books have animals on them, and they're all animals that I had to look up because they weren't just oh, here's a pig or something. No, it's all some endangered species somewhere that vaguely resembles something you've seen before, but it's not.
Yeah, to be fair, the cover of the Jira duck probably isn't a duck. It's probably a rare form of bird that looks like a duck.
Yeah. And I didn't know what it was either. When they sent it to me, I mean, they said, is this okay? And I said, what is that? And I don't even think they knew or whatever. Somebody knew, obviously. But I didn't find out what it really was or anything until the book came out and I could read that colophon in the back,
Nice.
That's okay. If it had been some awful animal, I would have said something. Let's put a piranha on the book, right?
Yeah, I read that O'Reilly and finished some area of O'Reilly. They queued yesterday, right? What was
right.
it?
Basically they decided not to hold any live events anymore, meaning they weren't going to have any more conferences. So things like OzCon is gone, and the software architecture summits, and several of the other conferences. They just decided to discontinue that entire side of the business, and that meant some jobs were lost as well. I don't have details other than the public post that was put out by President Laura Baldwin. Posted a nice explanation of all that. I don't have any information beyond that, but yes, it was a very big deal yesterday. it doesn't directly affect me. I'm lucky that way. I mean, most of my classes are online through the O'Reilly Learning Platform, and that's actually, if anything, getting bigger. So that's nice. Ooh, we got another picture.
Hello, Chandra. Hello, Sai.
There's a smiley in the window. Are those Post-it notes?
They are Post-it notes. I got the idea from a friend who now lives in Florida, but used to live in New York City, and got the idea from her friend who got the idea from a neighbor who did it across the way.
Very good.
So chain letter of happy faces.
Excellent. Excellent.
All right, people who joined, we didn't start yet. We have another 8 minutes before we start. We're just chatting. Feel free to ask questions.
Yep.
And welcome.
So we've got 64 people, it looks like, participating at the moment.
Yeah.
Oh, that Neha. I think I know Neha.
Yeah.
I'm not
Hello,
sure.
Neha.
I know a Neha. I don't know her last name. So I think that may be the one I know. But welcome, whoever you are.
Yeah.
Oh, no, I see your name. I just, but I also see the smiley, which is a good thing. This is the time when we'd normally be getting pizza, right?
Yes. Hey, Naveen from London.
You're not missing out. We almost never have
Nice.
pizza in New York City because office buildings have lots of rules about that. If you have pizza, you have to buy it from them, and it costs a fortune.
Oh, see the New England.
If you were on site, we wouldn't have been able to give you pizza at the event either, but we would have been able to buy you a beer after the event.
Yeah, that'd be a good trade, actually.
Perfect.
We got somebody from Chicago. Wonderful.
Chicago, and there is Naveen from London. Wow, it's late there. Thank you.
Where did you say? Oh, from London. Oh, fantastic. Nice. Oh, isn't that awesome? Yeah, so well, that's GMT. And what are we GMT minus 4 or 5 when we're on daylight savings time? Does that make us 4 or 5?
5, I think.
So they're 22:23 and we're 6:23. Well, we're 18:23.
So it's 4? Okay.
So it's 4 hours. Yeah, we're minus 4 at the moment. Thank you. Yeah, CVG, whoever that is, verified it also. Is Kotlin only for Android? See, that's going to go on the frequently asked question list. And the answer is no. The Kotlin can be used anywhere Java is used. However, the Android people have completely adopted Kotlin. It's Kotlin first ahead of anything. So that if you're going to be an Android developer, you definitely need Kotlin. But if you want to use Kotlin elsewhere, you can. The Spring Framework people in particular are very friendly to Kotlin. Yeah. It's a very nice relationship there. So we'll get into all that. But since somebody asked, figured I might as well answer right away. You know
a funny thing, Ken, when I joined a project with Kotlin, that was for a few months, 3-4 months I worked with Kotlin. And after that, a lot of people, hey, we have an Android position. We have an Android position. Say, no, I'm not an Android developer. Well, there's still this confusion, right?
I would describe Android as the killer app for Kotlin. I mean, most people don't learn a language just because they feel like learning a language. They learn it because they have some app they need to run or some API they need to work with, and Android is that for Kotlin. So if you want to do Kotlin, if you want to do Android, you need to learn Kotlin. Otherwise, it's optional. The issue about iOS is one of the things that JetBrains is really pushing is their multi-platform capability or the Kotlin native stuff, so that you could share the code for both iOS and Android and even a Mac and other platforms as well. They're really pushing that hard. I gotta say, as someone who's been in the industry a while, the history of cross-platform toolkits is a little dicey. So I'm still taking kind of a wait and see on that. So can you use Kotlin to develop iOS apps? Probably. Do I know any iOS developers who are using Kotlin? No. Okay. I mean, they're all like, well, why don't you Android people use Swift UI or something? So it's an interesting question, and we'll see how that develops. But there are definitely people who do multi-platform development by having the shared parts of the business use Kotlin, in the back end, everything. Mm-hmm. I'm still holding off.
Yeah. I never heard of anyone using Kotlin for iOS.
Well, if you want to hear about it, Hadi Hariri, do you know him?
I know who he is. Yes, I never met him personally. I know who he is.
Hadi's a dev advocate for JetBrains. Right. Oh, CVG, whoever that is, said they use Kotlin for IDEA plugins. Yeah. No, Hadi.
That's Chandra.
Pardon me?
That's Chandra.
Oh, really? CVG's an airport, so I don't. Okay. Oh, Chandra. God, thank you. Any rate, Hadi runs the Talking Kotlin podcast. That's probably the dominant podcast in the Kotlin community. And he frequently has guests on who talk about Kotlin multi-platform development. So I definitely know it's around because several people have been on there to talk about it. But I don't know that many iOS developers anyway, you know? So I don't know. I mean, I'm not a good sample size on that. That's one of those, I guess you'd say, anecdotal evidence pieces there. But I know the JetBrains people are really pushing it. I just don't know how quickly it's being adopted.
Nice. All right, 3 more minutes.
Yeah, you know, we're getting there.
Okay.
The countdown clock is nice.
You like that? I just Googled 15-minute timer or whatever, and that's the one that comes up. The thing is, if you ever use it, be very careful. You see this little, it looks like a speaker in the corner there?
Yeah.
Remember to mute that, because if here, I think I can magnify it. Yeah, see it there? Don't forget to mute that, because if you do forget, it rings like this really loud bell through your speakers. You're like, whoa, what the? And I've had my laptop connected to a projector, you know, through HDMI, and I couldn't figure out how to mute it. I mean, it was so loud. So don't forget that. But otherwise, yeah, it's free. It's easy. It's, you know, it's from Google. It's like I don't need a calculator anymore.
You got another question?
Yep. Can you run Kotlin on Windows 10? Absolutely. Yeah, no problem. I use, you can either do a download and install yourself, or there is what they call a Scoop installer. If you're familiar with Scoop, is one of those package manager programs on Windows. I've got a Surface Pro, I guess, and I've installed with Scoop. I've installed Kotlin on there along with a dozen other things as well. But yeah, I haven't had any trouble. All Kotlin needs when you're going to install it is Java 1.8 or above. And frankly, to be honest, you could do Java 6 or above, but don't do that.
Why would you?
Right. But you can technically, but I wouldn't. I mean, you really just need Java. And by that, I'd recommend 1.8, although I'll be using 11.
Okay. Have you tried 14 already?
I did run it and it did work, but I haven't done a lot of testing. I'd be nervous doing that. I have played with 14 myself, and now the latest Gradle version, Gradle 6.3, which became official like yesterday, that runs under Java 14. So my repos that do Java and latest and greatest Java are running Gradle 6.3 on Java 14. Everything works just fine. In fact, I have it with the enable preview stuff in there too.
Okay.
Yeah, Kotlin, they say, as Josh pointed out, it's about 5 years old, but really Kotlin 1.0. Kotlin didn't go 1.0 until roughly the same year that Google I/O announced that it was going to be adopted for Android. So I think that's, what was that, 20? Maybe they're right about the 5 years part. Maybe it was 2012, 13, 14, something like that. Kotlin versus Clojure too. I guess they're so completely different. I mean, they're both, the only thing that Kotlin and Clojure have in common is they're both JVM-based languages. I mean, one's basically Lisp. Oh yeah, thanks for the link for Scoop. Hey, is that our Frank?
Yeah, it's the Frank.
Yeah, the Frank, the RockStar.
Yeah.
Yeah, there's the Scoop link as well. Any platform-independent languages for mobile apps? Well, yes, if you're willing to code everything in JavaScript. I mean, the React Native, for example, or Titanium, or, there's a few of those. But then, I mean, I don't need more JavaScript in my life. Sencha Touch is another one. That's right. Thank you, Naya.
Happy New Year.
Okay. Right. So let me cut that down. And I'm ready when you are.
All right. So let's get started. JS. All right. First of all, thank you everyone for joining. This is our first ever 100% online event from NYJavaSIG. please post here on the chat where you're from. We see people from Italy, Chicago,
Awesome.
London. That's awesome. Thank you very much for joining. Canada, Jersey. Look, that's awesome, Ken. That's very nice. Thank you. Thank you very much for joining. Connecticut, New York, Paris.
Yeah, Paris. Oh, wow.
Hey,
Finland.
bonjour.
Oh, my goodness.
Bonjour, ça va bien? Merci.
South corner by you. That's Frank. Yeah.
All right. Finland. That's great. So first, we want to thank you, our friends. On the
Oh, you
Eclipse
want those?
Foundation.
Here you go. Or do you want this one first?
Sure. There you go. We want to thank our friends from the Eclipse Foundation, Jakarta IE, for giving the license from the Crowncast so we can be here showing, creating this event for you. So thank you very much. Please, if you don't know Jakarta IE, Eclipse Foundation, go to their website. It's amazing things, amazing projects there.
Sorry.
The Eclipse collections, it's very familiar to our friends here, the NYJavaSIG. There are several projects, open source. Feel free to join and contribute. Thank you. Now we're going to share some, that's all the ways. Can you change the slide now, Ken? Perfect. This is how you can be in touch with NYJavaSIG. So our website, nyjavasig.com. Our YouTube channel where we will be posting this video later, NYJavaSig. The Facebook, but where we are most active is NYJavaSig on Twitter. If you're not following us, please do it. We have over 1,000 followers there. The more followers we have, the better. More speakers we're going to be able to bring to you. More we learn together. So please join us, follow us on Twitter. So let's start. So our speaker today here is Ken Kousen. Ken, I was looking at your Twitter yesterday, and there is this thread on Twitter saying about the five jobs you had. And your list is amazing, Ken. Scorer from the minor league baseball, opera chorist, internal at a nuclear power plant, research scientist, and speaker author. That's an amazing list.
It's a mix. It's a mixture. I see Pratik wants the pizza. So do you want to fax him some pizza or email him a pizza or something?
Yeah, sure. Come on, Pratik. That's amazing. So thank you very much. But for all those jobs, you're here today for the last one, right? Software trainer, speaker, author. So Ken wrote several books. I would like to welcome to NYJavaSig. Thank you very much, Ken, for having us. We're supposed to meet in person on the past 19th, but with this COVID situation, we're doing the best we can. Thank you very much. So all yours, Ken.
Now, one question, maybe Gene knows, how do they make the slide area as big as possible? Because it looks like it's showing us as the same size.
Yeah, it's going to get bigger in a moment when Rodrigo hides his video.
Okay, I'll give him a chance to do that.
I'm going by.
You did, and then you came back, so you might have double-clicked it.
Do I need to hide my video as well?
No, we want to see you. You're the speaker.
Is there any way to resize it to make the one size bigger than the other?
Yeah, so people can do it. If you mouse over, don't do this, Ken, but for anyone who wants the video to be bigger, if you mouse over the slides, there's a focus screen. So just like when you watch a video online, you can choose to make it full screen. But we want to leave the default like that. Right. So perfect. Now everybody can see.
Okay, great. Let me start off by giving you a couple of resources. One thing I want to share with everybody is I made a shared Google Doc that this way it'll have something that outlasts the presentation. So on my screen here, let me make that a little bit bigger. You could see this. Let me close that up at the top. This document has all the contact information and the GitHub repository and a link to the slides and everything in it. And I took the URL for that, and let me copy this, and I'll paste it in the chat box. Paste. There we go. Oh, thank you. So somebody recommended the O'Reilly, the video tutorial on Spring and Spring Boot. Thank you. At any rate, this is a shared doc that I'll use to have information in it. And maybe I'll answer questions and stuff and just add to this if you want. So you're welcome to it. Now, the only people who can edit it, of course, Gene, because, Gene could do anything. Frank, okay, what the heck, and Rodrigo, of course. So if you need changes to it or what have you, then Gene can handle all that. But there's that, there is the shared doc anyway. Now back to the slides. I do have my contact information there. Again, my name's Ken Kousen. It's Kousen like the relative. It just doesn't look like it. We think it's an Ellis Island job or something. My one-person company is called Kousen IT Incorporated, or my wife pronounces it Kousen IT. It was her idea. So that's the sort of humor you can expect out of this, and I just want to apologize for that up front. At any rate, there's my email address and homepage and blog and Twitter handle, and I'm an older white male. Of course, I have a newsletter, so you're welcome to take a look at that if you want. That's up to you. Okay, moving on. I am actually certified as a training partner for Kotlin training from JetBrains. Just in case you're interested, just meant I had to take a test and everything. But moving on. Now, this is the other thing I wanted to share with you right up front. I'm going to do a bunch of code examples, but most of the examples I'm going to show you come from this GitHub repository that's in my GitHub account. So it's a github.com/my-last-name/Kotlin-cookbook. That's the book that we have now. And I think, Gene, did you want to say something about the giveaway, or should I do that?
Sure. At the end of the meeting, because you have to stay to the end, that's how we bribe you.
Ooh.
We're going to be giving away 3 electronic copies of Ken's book, which will be randomly drawn amongst the attendees. Also, at a future meeting, back in the future, when we all get to see each other in the real world again, we'll be giving away physical copies of his book as well. So you get 2 draws for Ken's book instead of 1.
So that's this book, this one called Kotlin Cookbook. A problem-focused approach. I didn't come up with a subtitle, but I like it. This animal on here, by the way, is called a kinkajou, which is some mammal that lives high up in the Brazilian rainforest, I think. And I don't know that the animal is endangered, although O'Reilly likes putting endangered species on the cover. I think it's more that the environment is endangered, and therefore the animal's endangered. This it looks kind of like it looks like a lot of different animals, but it's called a kinkajou anyway. I think it's a bold move putting an endangered species on the cover of a cookbook. That does seem a little bit interesting. But the real gag is that I showed this to a friend of mine who's not a technical person. And when they saw that, they thought that the animal was a Kotlin and that my book was about how to cook Kotlins, No, I did actually take a copy of my book in my local Barnes & Noble and took it and moved it over to the cooking section just to see what would happen. But when I went over there a week later, it had been moved back. So anyway, okay. So now let me give you some basics, and then we'll get into much more advanced stuff, because I imagine there are some people here who have already got some experience with Kotlin, and then there's probably a lot more who haven't done much of anything with the language. So I don't want to spend a lot of time on the basics, but I'll give you some of the basic fundamentals, and then we'll dive into examples, and I'll show the examples from the repository. So the language itself is a Java-based or JVM-based language, I should say. The compiler compiles the source code down to bytecodes. So it's not a transpiler or anything like that. It doesn't generate Java, although one of the interesting things you can do inside of the IntelliJ IDE is to take Kotlin code and generate the bytecodes and then decompile it to Java to see what Java code would be equivalent to that Kotlin code. That's not what the Kotlin compiler does. Kotlin compiler tries to make optimized bytecodes, but it's a nice way to check that things are behaving the way you're expecting them to. And I'll show an example of that shortly. At any rate, the language comes from an IDE manufacturer, which is a little unusual. JetBrains creates it and they maintain it. If you're looking to say, well, why do people use this at all? I'll get into more reasons as we go along. But the big selling point, the one that really seems to get a lot of attention inside of organizations, is the null safety capability for Kotlin. When you declare a variable in Kotlin, then unless you specifically allow it to be null, you can never assign a null to it or it won't compile. The code won't compile. So if you do allow a variable to be null, then you cannot do anything with it. You can't access its attributes or its methods or anything like that unless you have checked to make sure it's not null at that moment. So the compiler is very careful about avoiding null pointer exceptions. It's not that they can't happen, but they usually happen when you're interacting with, say, Java, which doesn't have the same level of safety. So at any rate, the null safety is a big deal in the Kotlin world that's designed, against that. Now, the other decisions that were made about the language is that it's got static typing, meaning every variable must have a declared type at compile time. So static there means a compile time, but statically bound too. And by static binding, what I mean is that all classes are final and all methods are final or implicitly final. So in other words, you cannot extend any classes, you cannot override any methods unless they add the keyword open to both of them. So Java is statically typed and dynamically bound. You can override things at runtime unless they mark things as final. But in Kotlin, you can't override or extend anything unless the open keyword was added to the original class. This is a big deal. It has some ramifications for the Spring framework, for example, which generates proxies by inheritance many times. We could talk about that a little bit later. The bottom line, though, is that it all runs on the JVM. You have classes, you have methods, you have all the sorts of things Java is expecting, and it's very common to interact with Java. And the Kotlin standard library is built on top of your Java standard library. So if you want to work with Java classes, you instantiate them and just invoke the methods as usual. And you could do the same thing from Java. You can invoke the Kotlin or instantiate Kotlin classes and invoke their methods exactly the same way. They're both object-oriented languages that have functional features inside. So the homepage for Kotlin is at kotlinlang.org. And let me actually show you that. So here is kotlinlang.org. And you can see that right now, the current version is 1.3.71. They always put that up in the corner. And they do talk about that mobile cross-platform and native and everything. So there's a lot to know if you want to try to do cross-platform development. But as I mentioned before we got started, I don't know. I've been in this field a long time, and I'm not. The history of cross-platform toolkits is kind of a dicey one. I'm kind of taking a wait-and-see attitude toward that. So everything I do in here and everything I did in the book actually is based on the JVM. So I stuck with that. Now, if you scroll down a little bit, they have an embedded version right here where you can actually run Kotlin right inside this browser. Like if I take this function and I hit the little run button here, it should execute, and it did in this case. And I can actually edit in here as well. So to give those of you who have a Java background some easy way to connect with this, let me address what's not here. Like the first thing that you don't see here is a class. I mean, in Java, you'd have to have your main method inside a class. And in Kotlin, this is what's known as a top-level function. It's a function inside a file. Now, what happens at the JVM level is that this file is converted into an actual class, and then this method or any top-level functions would be static methods in that class. So if you're thinking about the main method in Java, public static void main string array args, the static part is being handled by the fact that this is a top-level function. Kotlin does not have the static keyword at all, so they have to have another way to deal with that concept. And for that, they kind of borrowed from the Scala world. So if you've done any work with Scala, you're familiar with the concept of a companion object, and that's what Kotlin uses for the same feature. I'll show that more later. But this is simply a function in a file. Now, we can't tell from this browser what the name of that file is, but there is a file there, and that would determine the name of the generated class, and I'll show an example of that later. So at any rate, this is a top-level function. Now, in Kotlin, yes, you have to use the fun keyword to identify a function. There's some obvious puns that come from that, which I'm going to skip, fortunately. I don't want to inflict those on you. But if you're thinking also about the Java main method, you'd start with the word public. In Kotlin, interesting little design decision, classes and functions and everything are public by default. So we don't have to say public. Now they do have private, they do have protected. They also have something called internal, which is sort of module scope, but not in the Java module idea, more like an IDE module scope. It's something that makes sense in JetBrains, you know, in IntelliJ. I'm not really going to deal with that. It doesn't come up that often, but it's an additional access modifier. But this one is public because you don't see anything on it. So public static void, well, main's supposed to return nothing. In Kotlin, they don't have void. Instead, they have a class called unit. And if I execute this again, you'll see that I haven't changed anything. The return type on a Kotlin function goes after the signature. And that's a common pattern we're going to see. So the colon indicates there's a return type. In this case, the return type is unit, meaning nothing. So that works either with that or without it, as you saw, either way. If we were returning something like a string, however, we would have to change the return type to string. Now, the next part, public static void main, well, the name of the main function is the same as the main method in Java. And then string array args. Well, in Kotlin, as of version 1.3, if you don't use the arguments array, you don't need to declare an arguments array as part of main. But if you wanted to declare it, it would look like this. You'd say args is of type array of type string, and array is actually a class in Kotlin. Now, they still use square brackets to access elements in the array, but you instantiate them using the class. You don't declare them the same way you do in Java. Plus, they're using the same generic or the same angle brackets for generics that Java uses. So that's quite familiar. So this is an array of string. And again, I haven't really changed the behavior here. I'm not using them anywhere. Now, the question about, like, what about primitives actually is an interesting one. And let me say it this way. In Kotlin, if I wanted to declare an integer, I would say val or var, we'll get to that in a minute, x is of type int. And they have a class called int. I don't know why they shortened it from integer. I mean, what difference, right? But that's the class, and they don't have a primitive necessarily. However, because we're still compiling down to the JVM, if you declare this as int and it's not nullable, then it will try to compile it down to lowercase int on the bytecodes. Whereas if I say int question mark, meaning that it can be null, then it will use the integer class. See, because that's the only one that could be null. So these are the sorts of things that you play with inside of Kotlin to get better efficiency and so on. And we'll get back to all that stuff. I just wanted to give you an idea what that looks like. Okay, the other thing to point out about this before we leave it is that there is a top-level function called println. And when we move to the IDE, you'll see, in fact, println is a function declared in a file, much like this one. And much of the library is declared as top-level functions in various files. And println is scoped to a package, but it's a package that's automatically imported. And in this case, it takes a string. And yes, the string is double quoted, just like in Java. Okay, so that's about all that there is to see about the basic main function. Let's look at the object-oriented hello instead. And now things are a little bit more interesting. Now let me run it first just to show that it's working. Hello, Kotlin. So here's our main function again. This time it does have args as an array of string. But notice here, this greeter is a class declared up here, but what's different is you don't see the keyword new. So Kotlin doesn't use the word new to instantiate classes. You just write the constructor without the keyword new. And then the parentheses here are indicating which constructor to use. And you can see Kotlin declares a primary constructor even before you hit the parentheses here. Now, or the braces, I should say. If you've played at all with Java 14, the new one that just came out this month, this looks vaguely like records in Java. Java has a record that allows you to put in basically the primary constructor before the braces. But here, that's normal in Kotlin. You can add additional constructors, but that gets into something different. Now, one thing I want to mention about val here is that there's val and there's var. By the way, all this is in the slides. I just want to focus on the code instead. So val means value and var for variable, but they have nothing to do with the data type. See, the data type comes after the variable. Name is of type string. What val basically means is final in the Java world. So val means you can't change it. That's all it means. And var means you can change it. And yet the Kotlin IDEs and the compiler will be putting subtle pressure on you to use val wherever you can and var only where you have to. So they really are trying to push the idea of doing things with immutable objects as much as possible in a function type of approach, very similar to functional programming in Java or Scala or many of the others. Now, there was a question about can these be static as well? And as it turns out, not this way. There's other ways you could make things static. So not the way this is listed. This greet function is an instance method is what we call it in Java, but it's an instance function here. See, this is instantiating the greeter class. So we're not invoking it from the class. We're actually invoking it from an instance. So in fact, if you wanted to see it, you could say val greeter equals greeter arg0 like that. And then I could change this to the lowercase one. And that's the same exact behavior there. So it's just they chain the method call to the instance. That's all. This just emphasizes that you're not using the word new, but it is an instance function. Now, the other thing that you see here is that they're doing string interpolation. This is kind of borrowed from Groovy. So double quoted strings allow you to put a $sign inside, and it's actually short for this, $, curly braces, like that. So I could put my exclamation point after it, for example, hello Kotlin. And I can't see where the argument's being supplied. Again, that's internal here, but it's clearly the word Kotlin. But I could invoke a method like to uppercase like this, and you see that everything inside the braces is evaluated as Kotlin. If it takes too long, I'll just go to the IDE, but there it is. It will eventually return. Any rate, everything in the curly braces is invoked, and whoops, it did. I got back a cache value because something failed. I usually just have to hit run again. And again, if it starts being flaky, I'll just go to the IDE and show it to you there. If I left out the braces here, I would run into problems because what would happen, again, it's something's flaky there, is that if I run it this way, it will consider the rest of this to be part of the string, not invoked on this variable. So there's the idea. So, all right, there's a primary constructor taking a single argument. I can also put in a default one here. See, again, I'm having difficulties with the online system, but that's all right. I'll go to actual an IDE and show you the details. But there's a class, there's a function, there's your top level function, there's an instance, there's a method call or a function call, as they say here. That's the object-oriented approach. And again, the class is public by default. The main method is public by default. Everything in here is public. I don't have to say public. I can say private. If I said private here as a private function, then this will not compile. Now we got its attention. It's private and greeter. So you do have the concept there. It's just by default, it's not. Okay. So we're going to get into more. There, finally, that woke it up. So again, if I want my braces in there, let's put my brace at the end of the expression and run it. And now it'll invoke the to uppercase method. And there you are. Now, one other thing I want to show you, actually, I have to, Gene, I'm stealing a little of your thunder. I happen to be, I'm able to see some of the things coming up in the chat box, so I'm going to address a couple of them as they come up. There's a question that says parameters need types, but local variables do not. They do, actually. Everything needs a type. The local, if you're not seeing val or var, again, that has nothing to do with the type. That's basically final or not. Now, we'll talk about where you don't need to declare the type, but the types are still inferred by the compiler under certain circumstances, and we'll see that. Now, because we have a limited amount of time, I don't get to show you one of the other really major capabilities of Kotlin that's getting a lot of attention, but they have an example right here, so I thought I'd mention it. It's called coroutines. So coroutines is a mechanism in Kotlin that makes it easy to write code that's running asynchronously without massive callbacks. Now, many of us are already accustomed to writing code without callbacks by using, say, reactive streams, RxJava or Project Reactor and the Spring Framework, etc. And in the Kotlin world, they use things like that, but now they have these coroutines, and that is slowly displacing the idea of reactive. Now, it's not that you can't. Let me rephrase it. They're both competing with each other right now, and I get the feeling that the coroutines one is eventually going to win. But it's not like you can't do both if you want, or pick one or the other. Now with Java 8 streams, it's different, but with parallel streams, there's at least an analogy to it. Okay, but this truly is asynchronous code. Now the suspend keyword is what's telling Kotlin that when you compile this, this is a function that can be interrupted and then run something else and then come back and resume it later. So it's telling the compiler that at runtime, you can interrupt this and it'll save the state and resume it. This is a function called coroutine scope that takes as an argument this whole block here all the way to the bottom. The open brace here, the closed brace here are basically a lambda expression, which has a slightly different syntax than the one in Java. Java also has lambda expressions, but it's a similar idea. In fact, the syntax that Kotlin uses for lambdas is exactly the syntax that Groovy uses for closures. So if you've done any Groovy, that'll look familiar. What coroutine scope does is it coordinates a whole bunch of coroutines. This is known as structure concurrency. What it basically says is if you launch a bunch of coroutines inside this block and one fails, then coroutine scope will make sure to cancel all the remaining ones. So it's a way of coordinating a whole series of them. And you can see in here, they're doing a launch function to start up what turns out to be 10 coroutines. Now this for in loop here, coroutine scope is not a keyword, it's a function. So what you're not seeing, unfortunately, in here is the actual import. In fact, that's not a bad segue. Here is my GitHub repository for the Kotlin Cookbook opened up inside IntelliJ IDEA. And here is, in fact, that same example on the coroutines homepage. And let me actually make the fonts just a little bit bigger here now that I'm thinking about it. So let me make it, say, 24 point. Maybe that'll be maybe even easier for you to see. So this is the same exact program, but you can see here that coroutine scope is actually a top-level function, and it's imported from the kotlinx.coroutines package. So coroutine scope is using, in this for loop, it says for I in 0 until 10, and you see the colon int here. Now that's not in the source code. That's simply a an inferred data type, because this guy 0 until 10 is actually what they call a range. So this is all the values from 0 to 9. Actually, the word until means 0 up to but not including 10. If I wanted to include 10, I'd say ... And now that's 0 to 10 inclusive. So that would be 11 instances rather than 10. So instead, they did until. And you could see actually until is a function. And in reality, it's what we call an infix function, because you could see it appears in between the arguments between 0 and 10 here. And it doesn't require parentheses or anything. But that's a whole different issue. We'll get to that. Okay, so I is in the range from 0 to 10, and in each one we're going to launch a coroutine at a delay. Both of these are top-level functions being imported. The delay is, as you can see here, takes a long as the time in milliseconds and returns unit. So it delays a coroutine for a given time without blocking a thread and resumes it after that time. So here you can see they've got 1,000 with a capital L to indicate a long minus I times 10. So they're going to run this 10 times, and each time they're going to do a print with the Unicode. That's that little heart, was a Unicode character with $I and a space in it. So let me execute this, and I'll show you what it does. And then there's a couple other interesting features to see, and then we'll go on to a few other interesting features on that. Yes, I have replaced my progress bar with something called Nyan progress bar, which is a little Nyan cat, just goes back and forth. At any rate, you can see that each delay was shorter than the previous. You know, this one's a full second, then the next was 990 milliseconds and 980, 970. So these actually printed out in reverse order, including that extra space at the end there, but you could see the integer printing out. And this is how they're able to do concurrency in a function that looks like it's written synchronously. Let me simply caution you is that, and by the way, these are not all separate threads. Coroutines are lightweight threads. You can have, in fact, you know, you can only instantiate a certain number of threads before you run out, but you can launch thousands or tens of thousands of coroutines, and it's the runtime environment's job to distribute those among the available threads. So let me emphasize one thing, and then we'll go back to a few other things here. And it's that just because it's easy to write asynchronous code doesn't make asynchronous coding easy. You know, that's the thing I want to emphasize. There's plenty we could talk about with coroutines. In fact, we could spend the whole time here on coroutines, and that would get well beyond what I know. I still consider myself to be okay at coroutines. There's a lot of moving parts. The good news is that the number of use cases is fairly small, but there are a lot of moving parts. Now, Java is adding eventually, I think it's part of Project Loom, is what they're adding fibers to the language. And that will be very similar to this coroutine idea. And then we'll see how the language responds when Java has something similar like that. But that's what I wanted to show you here. Now, let me close. Oh, before I close this, let me go inside the print function, for example. If I access it internally, you can see here that this is what I mean by a top-level function. The name of the file here is called console.kt, and then inside, here's a function at top level, public. Now, the actual one is part of that multi-platform stuff. The idea is that you could declare functions that need to be implemented on the different platforms, Java versus JavaScript versus some others. This is the actual one implemented on the Java platform. So, of course, it's just turning around and invoking system.out.println. Now, message is of type any ? Any is the superclass of every class in Kotlin. So it's like Java's object, but for Kotlin, and it's a nullable any, as they say here. See, it's, as they say, public open class any. Let me magnify that. Class any, the root of the Kotlin class hierarchy, every class has any as a superclass ultimately. And any is actually remarkably simple. If I look at that, then you can see there's the open class so that it can be extended. Here's your open operator function equals, which returns a Boolean. So that would be like overriding your equals equals operator. Here's your hash code function, which returns an int. And there's your toString method, which returns a string. And that's it. That's the whole class. So all classes extend this particular class. Now, any is fairly intuitive. The fun one, of course, is the one called nothing, but we're not going to get to that for a while. Okay, back to the slides for a moment. So let me go on. So for any language, some people just like learning languages, and I respect that. I think that's great. But if you're like most of us, you don't really have time to learn a language unless you have a reason, something that's kind of driving you in that direction, you know, to say, oh, I need to do a particular task or something like that. Well, the killer app for Kotlin is Android. Google announced about 5 years ago that they were going to support Kotlin as an Android development language. And then a couple of years ago, they announced that, in fact, they didn't quite endorse it. They basically said all of our examples that we're showing online will show in both Java and Kotlin. They really were clearly moving in that direction. And then it was a year ago at Google I/O, they said, yeah, you know what? Now everything is Kotlin first. So if you're going to develop an Android, you could still develop applications in their Java API, in their SDK, but if you're looking for a job in Android, you'll probably want to have some Kotlin background. And this has driven an enormous amount of Kotlin adoption. Right around the same time, Kotlin went 1.0. That helped adoption as well. It made it really grow. So if you're an Android developer, then Kotlin is definitely something you want to learn. However, you can use Kotlin anywhere you use Java. You can use it very heavily in the Spring framework, for example. The Spring people are very friendly to Kotlin. They have some DSLs they created, domain-specific languages built on Kotlin. They use a lot of Kotlin features. There's some tutorials. It's really nice stuff. So eventually, Kotlin may become a significant language on the server side as well. I'd say it is significant, but we're still talking very small numbers compared to the number of Java developers, if you will. It'll be interesting to see over the next year or two how it grows relative to Groovy and Scala and Clojure, the other alternative languages on the JVM. Now, of course, JetBrains makes available IntelliJ IDEA, and they also contribute Android Studio in conjunction with Google. So if you're an Android person, use Android Studio, which is kind of a stripped down freeware version of IntelliJ with the Android plugin inside of it. You don't need the commercial edition of IntelliJ to do Kotlin. It comes with a free version as well. So it's a plugin there. There is an Eclipse plugin maintained by JetBrains. I mean, no conflict of interest there, right? And I've heard mixed things about it, but it does keep getting contributed to. It is in their best interest to get people to use it, but I wouldn't do that. I would use one of the free IDEs, you know, IntelliJ IDEA Community Edition if I want to get involved. Now, again, the basic syntax, you declare the variable name or the variable type after the name, var for variable, if you will, val for value is immutable. Immutable is a strong term, carries a lot of baggage with it. It's basically Java's final. So you go with that. Again, if you want to make it nullable, you put a question mark on the end. If you have a variable and you declare it to be of type string and you assign it to a null, it will not compile. If you do make it nullable, you can't invoke a method like length on it unless you've checked that it's not null. Again, that won't compile. Now let's move to something a little bit more interesting right away. This is called a data class. A data class is in Java what we would have called a POJO, except it also has a toString method, an equals method, a hash code method. There's a couple of other really interesting methods I'll talk about later, but it has at least those. And in fact, again, the closest analogy in Java is a record. One of the ones that have been announced in Java 14. I mean, and it's also effectively final here, although you can open a data class, but just like records are final as well. If you've used Lombok, for example, the Lombok library in Java, and you use the @data annotation, you're getting essentially the same thing. Now it says generate getters and setters. Since both of these properties are val types, they don't have, it doesn't generate setters. You can only modify these with the val types. Now the copy method is like a copy constructor. The component end methods are very interesting. Now, if I go to an existing one, let me open up an existing one here. So I think I have a class called, for example, person. So here is my data class called person, and this is pretty idiomatic in that I'm writing it vertically just so I could see the attributes. But notice there's no braces on this. This is just the primary constructor. I could write it all as one extended line. That would be perfectly fine, but I didn't, but you could. Now, I have a test here, and all my tests, by the way, are using JUnit 5. So I didn't use one of the testing libraries from Kotlin. I'm still kind of taking a wait and see attitude on those to see which one wins, you know, which one becomes the default. But I like JUnit 5 a lot, and JUnit 5 works perfectly well with Kotlin. So for example, here, I've got a first and a last property which are not nullable, and I have a string property that is. Middle is nullable. So I can instantiate a person. Again, notice there's no new keyword here where I put in J.K. Rowling. I don't know if you're aware, but J.K. Rowling doesn't have a middle name. Her name's Joanne. K comes from her mother. You know, she adopted that. And therefore, I can assert that that's null, you know, that the middle name here when I instantiate the person supplying that. Now, what I could have done, but I didn't, is you could put in default parameters, but if I'm going to put in a null, then I need to make this a var parameter, if I will, so that I could modify it. Actually, I don't in this particular case, now that I think about it. So at any rate, let me undo those changes. Just saying that Kotlin also supports default parameters, both in function calls and in constructors. So down here, I could say, let's access the middle name and get its length. But if I took off this question mark, you see how I get an error immediately. The error says, let me see if I can magnify that, only safe or non-null asserted calls are allowed on a nullable receiver of type string question mark. In other words, what they're trying to tell me is, hey, you said this was nullable, and therefore you cannot invoke anything on it unless you check that it's not null. Now, this safe call idea, again, is borrowed directly from Groovy. So the idea is you go question mark dot, and the compiler is going p dot middle. Is middle not null? Yes, then I'll invoke the length property. Otherwise, it returns null. And the inferred type of middle name is int question mark in that particular sense. The is function here is instance of in Java. So you can't set something to null unless you declare it to be nullable. And that's what's being done here with the question mark. Okay, so anything else here? Oh, here's the non-null assertion, which is almost screaming for it to come up on a code review. The bang bang operator basically says, oh, believe me, compiler, it's not null, I promise. But that's guaranteed to come up on a code review. So otherwise, you can use the null assertion. Now, this time, in this one, I asserted that it was not null in an if statement. And then, I don't know if you could tell, but this is in green because what they call this is a smart cast. And what they did is they took that string question mark and cast it to string because we checked that it wasn't null and it believed me. Now, if this middle had been an attribute, that wouldn't have worked because it's possible to change an attribute into a different thread. But because it's a local variable, the way they're accessing it, then the smart cast works on all of that. So I think that's everything I wanted to comment on here. Yeah, good enough, just to give you an idea. Now, let me show you one other. Oh, the backticks around the test functions here are a way of writing an actual string for your test name. If you try doing that inside of regular code under your source main Kotlin hierarchy, if you will, then you'll get a warning saying, please don't do that. But in tests, that's considered fine. That's considered normal. So this is a regular JUnit 5 test case. That's the org.junit.jupyter.api test annotation. And you can put in descriptive names for the tests like that. And that's pretty common. So showing you that. Now, one other thing I want to illustrate is I'll go into the tools menu here. So let me magnify that again. So I'm under the tools menu. And then under Kotlin is show Kotlin bytecode. So if I select that, then you can see the bytecode. But what I really want is this decompile button. So if I click the decompile button, then this is the Java code you would have seen had it been written in Java. So let me skip the person test and go down below to the person class. See, this is what the Java code would have been like. And you can see it's labeled as final. The attributes are all labeled as final, and they use their own JetBrains annotations for not null and nullable. And of course, they would love it if everybody in the Java world adopted those annotations too. You can turn on a flag in the build that allows it to work with other nullable type annotations that are part of the JSR. I think it's JSR 305 or whatever. You can make those available as well. In the Android world, of course, the Android SDK is written in Java, and it's not like they're going to port the whole SDK to Kotlin. So they're constantly thinking about the interaction between Java and Kotlin and all of this. So here these fields are final and not null or nullable. There's your getter methods that were auto-generated. Here is your constructor with the elements inside it. And there are those, this is what triggered a lot of this discussion, there are the component methods. So a data class automatically generates component end methods, in this case 1, 2, and 3, and each one returns one of these attributes, basically fields top down as they're declared in the class. And what that's used for is something called destructuring, which I'll get to a little bit later. There's also your copy constructor, which is really a copy method, but it basically takes an element and makes a copy of it. And then there's a toString and a hash code and an equals, and you could read all the details. But again, I don't really care about the details of the Java code. I just did the generation so you could see how some of the concepts carry through to things that you may find more intuitive. Okay, so that's a data class. Let me go on. Now, functions, again, all require the fun keyword. You have to put that in. But something I didn't emphasize, and you might have noticed it when we looked at the coroutine example, that they actually had an equals at the end of the function's signature. This is fine if your implementation is a single expression. So one long extended statement, like in that coroutine example here, let me go back to that. See, the coroutine example has an equals with assignment to this function called coroutine scope, and the coroutine scope braces go from here all the way down to the bottom. So this is just one giant function call, and therefore you don't need the braces on the main function. You could just assign the function to an equal sign. And this happens in Kotlin a lot. And in fact, there's again, strong but subtle pressure to kind of drive you to write this way. And some functions exist in Kotlin to make this whole thing easier. So in the slides, you could see, like if you had a say hello function that took a name of type string, you could simply assign it to println. Now, this isn't as common because println returns void, returns unit, so there's nothing to return, but still this would be legal. Also, the semicolons are not required, but just like in Groovy, they work if you add them. Okay, moving on. Here's a better example to really illustrate the single expression functions. This is a sum function that takes two ints and adds them up in all its glory. You can see A and B are both declared to be of type int. The return type is declared of type int. They use the return keyword. But then you notice that this is a single expression. And therefore, there's no reason you couldn't just say equals, and you don't need to put any return types here or anything like that because they're inferred from the argument list. And again, I don't need the return type on the function because that's inferred from the expression on the right-hand side. And I bring this up because, again, it's very idiomatic to code this way in Kotlin, and you'll see this in many functions in the standard library as well. They're constantly writing things this way as a function with variables equals some extended expression like that. I really like that. I kind of miss it when I go back to Java and I don't have that. Now, what I was trying to illustrate before, but I didn't pick a good example for it, is that you could put in optional, or rather, I guess I should say default values for the parameters. So this is from the standard library. The read function in the standard library reads from a byte array, an array of bytes, at a given offset for a given length, but they specify the default offset to be 0 and the default length to be the size of that array. Notice how they can still use this variable on the right-hand side here, even though they just declared it as part of the signature. It's kind of neat. So this one is actually 1, 2, 3, 4 different versions, I think, of this function. I could write it read with a single argument just being the byte array, or read with an array and an offset, or an array and a length, or array and offset and a length. And with Kotlin, you can invoke functions both with positional parameters or with named arguments. So I'll show you could use the names as well if you want to go through that. Okay, moving on. The if statement, and this is another neat feature of Kotlin that I kind of wish Java and Groovy had. The if statement returns a value. So you don't have to say, for your max value, you don't have to say if A is greater than B, return A, else return B. You just say max equals, and the if statement returns a value. Now, again, one of the features that's now official in Java, starting in 14, is the enhanced switch statement. And the enhanced switch statement's like this. It returns a value. But here we have it in Kotlin, even for the if statement. And it acts, so basically they don't have a ternary operator because the if statement is a ternary operator. You're just writing it on its side. If A greater than B, A, else B, like that. And for the switch statement, then they have when. Now, the question that came up again is, does it compile an int down to integer, or does it use the primitive? And it really comes down to whether you made it nullable or not. If you made it nullable, it becomes integer. And if you don't make it nullable, it tries to make it int, but then other factors come into play as well. Okay, so here's a when statement taking an expression. Now, this would be inside of a bigger loop that would set the X value, and get the modulus operator just like Java. And they're using the same arrow notation that, again, Java's enhanced switch statement in 14 uses. So notice there's no break because there's no fall through. So the 0 value for this expression would return this string, and the 1 value would return this string. And the when expression must be exhaustive if you're returning a value. Now, if I wasn't returning a value, if I was just printing these, then I could get away without it being exhaustive. But because I'm returning something, even though this actually does cover all the cases, Kotlin doesn't know that, so it requires an else expression as well. So I just put in Houston, we have a problem in case we have something like that. And then I could use the variable outside it. So there's that. Okay, you can make when a bit more complicated. In is basically the contains method, so that I could take a range here and say if X is in this range, I could print out something about that. Is instance of, so this is an instance of the float class. I could do a not in, you could do a lot of things. And then again, I have an else because I need this to be exhaustive, but that one I would have needed exhaustive anyway. You know, there's a lot of options there. Okay, the for in loop is available as we saw already, so I'll just skip that because we saw an example of that. Array being a class means we have properties on it. One of the properties on array is indices. So this would return a collection of all the index values, and therefore I could use the index values in the square brackets. So I'm basically trying to show that the square brackets here still work when I'm accessing values in an array, but when you iterate over them, you need to retrieve the index values because they don't have the traditional Java loop that would return them. And with this in mind, here's a function called withIndex, and that returns a class that has both index and value in it. And this is where we're going to start getting into that idea of destructuring. So index and value are the two elements here. Now, let me show you what I mean by this. So over here, let me go to the top and I go to learn here. And this takes me to the reference guide. And the search box is actually very useful. So if I go to the search box and I say with index, it says, oh, that's a function in collections, returns an iterator that wraps each element. It's also on sequences and on text, but I'll just go with this one for the moment. And you could see that on iterable, or rather with index on array and any of the special types of arrays, or on iterable, this is the one I'm using at the moment, on iterable returns, I'm sorry, I did it again. That's char array. Here's the one on iterable. Okay, I thought it would be listed up here, but it's actually here. Iterable has a with index function that returns an iterable of index values. Now there's several things going on here. So I want to mention something about this so that I can show an example in a moment. Okay. So first of all, this is what's called an extension function. Now in Kotlin, it is considered normal to have a class with only the minimum elements you need in it, and then add additional functions to it, like with index. The fact that they have a function with a class name dot function name here means this with index has been added to the iterable class. Iterable is the same one from Java, by the way. And then it has an implementation, which we don't see at the moment. But the return type is an iterable of whatever they're calling index values. Now, I'm going to show you an extension function later. I'm going to get to one that's very useful called pair, which comes up a lot. But let me hold off for that for a minute. Notice that with index returns this index value object. And if I look inside index value is a data class, which has two properties in it, index and value. And finally, the reason I brought this up in the first place, this is a data class and therefore has a component 1 and component 2 function in it. Component 1 returns the index, component 2 returns the value. And after all that, that's what leads us to this destructuring. So when you are returning a class that has those component methods in it, you could assign it to something in parentheses that has several dummy names. Now, I didn't have to use the word index and value here. These are just dummy named arguments. But instead of returning that instance of a class called index value, I'm destructuring it to index and value. And the way it's doing the destructuring is by invoking that component 1 method and the component 2 method. Now, you could add your own component methods to any class you want, but data classes have them automatically. So now inside here, I could just say the element at this index is that value. Now, that seemed rather elaborate, but here's a case that comes up all the time. Maps. For example, yes, exactly. How to destructure maps. Now, let me show you an example with maps in the source code here. So I have under collections here. So let's see. You know what? I'm going to write a new one. I'm just going to write something simple. And to keep this clean here, let's see. Git checkout -b NYJavaSIG. Okay, so I made a new branch, so I'm not changing anything. So let me do a Kotlin class or file called map demo like this. And you see now it's a top level function or top level file. I don't have a class in it. And what I'll do is I'll put in my main function. Main would just make a regular main method. Main A would make it with the args, but I don't need the args here. So I want to create a map. So let me put in a class. Well, actually, I'll just make, I'll just do one with some strings. So I'm going to say I have a map which will be A to 1. Actually, let's do it this way. Map is a map of. How about this? Now, map of is a function in Kotlin.collections that takes either a single pair instance or a vararg of pairs. See, notice how they use vararg as a keyword to represent ... like we would use in Java. So how do I make a pair? One way to make a pair would be to instantiate it. I'll make a pair of A, comma 1. But I want to put in a second pair. So I'm going to use B to 2 and C also to 2, like this. And if I print line my map, what you'll see is that it's giving me the normal toString method on a map. Now, the data type being inferred here is a map of string comma int. And it's like, well, wait a minute, what are these pair things? They're basically like map.entry instances, but it's a bit more than that. If I go drill inside, let me go drill inside the pair class, you can see this is a data class. Now they put in the word public, but they don't actually need it. But data class pair takes two output variables. So that's how they handle their generic types with wildcards. Instead of using question mark super or question mark extend, they use in and out for covariance and contravariance. A and B are output types here on pair, but they're generic types. They could be of any type. And then they have two public properties, first and second, which are val types that can't be changed, of type A and B, whatever the heck A and B are. And the class implements the serializable interface, which is the same serializable interface we know from Java. And then inside the braces, the only thing they've done is override the toString method. And notice how they use the single expression implementation here to print out parentheses first and second, just like that. So there's an override. Oh, somebody likes covariant and contravariant. Well, that makes one of us. Sorry, but you know, at any rate, if you love covariant and contravariant, you're probably a Scala developer. But at any rate, Kotlin has some of this stuff here. Now, var, again, would be a variable, meaning I could change the value. Val is basically final. So val is final in Java. So notice how minimal this class is. All it has is the two properties and a toString override. And then down here is actually, no. Yeah, okay, I'll go with this one. This is an extension function. So now pair is just a holder. In other languages, they would have called it a tuple, you know, like in Python, they call it a tuple or a tuple, however you pronounce that. It's just a combination of one A and one B, whatever A and B instances are. And here they've added an extension function called TO to class A, whatever class A is, that takes as an argument that of type B, whatever B is. So you see, this is an infix function, meaning the 2 goes in between A and B. It returns a pair, and how it does it is instantiates the pair class using this and that. Yeah, tuple in other languages can be more than 2. Here it's exactly 2. Well, here it's not called tuple, it's called pair. So pair is exactly 2. By the way, you may have noticed when I scroll down here, there's also a triple, but that's not nearly as common. Okay, so here is 2, which instantiates the pair class with this and that and returns it. So back in the code that I was writing, here's the 2 infix function. So in other words, it's perfectly legal for me to write it as b.2 parentheses number 2, and immediately I get a warning saying, you want to replace 2 with its infix form, because they prefer I use the other syntax, which means sure. And then I'm back to this, which means I could have written this one also as a.21. Let me reformat. And what you see is I basically am showing you a top level function, a pair class with an extension function that's an infix function that's creating a map that's being printed out. I mean, it's just going all over the place, you know? It's using a lot of features from there. Okay, let's iterate over the map to see the destructuring. So for key comma value in map, let's print line $key maps to $value. And now when I execute this again, you see that it is doing the destructuring on there too. And the destructuring is working because it's returning all these pairs, and pairs are data classes. And data classes have the component end method. So it's connecting all those pieces together. Okay. So that's what all this was about. But you could do this with any data class because data classes have the component end methods, make them somewhat easier to iterate over. All right. A couple other little things, and then I have some much more interesting stuff to show. So first of all, they have an Elvis operator here, which comes directly from Groovy. Now in Groovy, it makes a certain amount of sense because Groovy has a ternary operator, and what Elvis really is this a limiting form of ternary operator. This basically says, what is the value of S? Well, if person.name is not null, use it, return name, else use world. So Elvis is basically saying, what happens when name is null? So when name is, so if I put in name and name was Dolly or whatever, the value of S would be Dolly. If name was an empty string, S would be an empty string. If name is null, S is world. But it's funny because this is the limiting form of a ternary operator, and Kotlin doesn't have a ternary operator. I mean, really, Kotlin takes features from lots of other languages and then kind of bolts them together. It's a bit of a Frankenstein monster in that sense. There's those people who know Scala see lots of Scala in it legitimately. People who know Groovy see lots of Groovy in it. You know, it pulls things from all over and puts them all together. Okay, let me talk about lambdas. And then, Gene, are there questions that we should be addressing?
Yeah, a couple. Do you want them now or after your Lambda slide?
Okay, I'll just say something about the lambdas, and then I'll take a moment to deal with that. Okay, the lambda syntax looks like the Groovy closure syntax, not like the Java syntax. In Java, then A and B here would be in parens, and then I'd have an arrow and an expression, and I wouldn't have braces at all. Or if I did have braces, they'd only be on the right-hand side of the arrow. You know, if I didn't have the braces, then this would be an expression lambda. If I did have it, they'd be a block lambda. In Kotlin, as in Groovy, the braces surround the entire lambda. But also, it's idiomatic that if in Kotlin, the lambda is the last argument to a function. Like this is saying I have a max function that takes a collection of strings, and here's the lambda that's basically the implementation to compare to say, I want the max one by this comparison, you know, basically the longest one here. Well, if the lambda is the last argument to a function, you put the lambda after the close brace or the close paren here. And that's considered pretty idiomatic. One last thing about lambdas before I start showing some more details. You can assign a lambda to a variable. And in Java, there's no class or interface called lambda. So Java uses functional interfaces, you know, an interface with just a single abstract method in it. In Groovy, they have a class called closure with a call function, etc. In Kotlin, they didn't do either. In Kotlin, if you say, well, what's the data type of sum? And it's this. It's 2 integer arguments that yield an integer return type. So when I assign this lambda to the sum variable, this is the data type. And you see this sort of thing in the library all the time. I'll show you some library expressions. Like, for example, actually, let me show you max by. So on collections, here's max by, which says on any comparable, let's do it on an array. On an array, max by takes a selector, and you see the data type. The data type is a lambda that takes one argument of generic type T and returns a value of generic type R. And the overall function returns a comparable, actually the function returns a nullable T. I should say it that way. Now, the reason the function returns a nullable T is because if there are no elements in the array, it's going to return null. But otherwise, it extracts the maximum value of the array based on this selector, where T is any generic type and R is a type that implements the comparable interface. That's the idea. Okay. So here's an example. They said list of Alice to 42, Bob to 28, Carol to 51, max by with the lambda. Now, if you have a lambda that takes only a single argument, like they're declaring, and you don't give it a name, if you don't give the dummy argument a name, then the argument becomes the word it. So this is saying max by it dot second. Remember, each of these is an instance of that pair class, P-A-I-R, and pair has a dot first and a dot second. So this is saying the max by second, which is the age here, and that returns the oldest person, like that. So there's a combination of all the things with a lambda and more. And that actually, by the way, there's that it mechanism inside a single argument lambda here and there. There's a bit of a natural break. So what questions do we have that you'd like me to address?
So first of all, Justin's been doing an awesome job answering questions while you were talking. So I'm only going to be asking questions that have not been answered yet. The first one is a fun one. Why is it called the Elvis operator?
Oh, okay. Really, really dumb reason. Really dumb. If you turn your head to the side, most people turn it to the left, then this is supposed to vaguely resemble Elvis because the hair's got the little curly Q on it and those are his eyes. It's a reach. I sometimes think if you turn your head to the right, then that's the mouth with the turned down mouth like that. I don't know. It's really a stretch. But yeah, the term's been around for years. Mostly, I think, came out of the Groovy community, and Kotlin just borrowed the whole idea.
Okay. The next question, which was partially answered, but I'm going to ask anyway because I think it's a good one, is how does Kotlin differ from Groovy?
Kotlin, again, is completely statically typed. There's no def. There's nothing that corresponds to def in Groovy. There is... It's much more locked down. It's statically bound also. So you can't overwrite anything that doesn't have the open keyword on it. The libraries are not as mature. I honestly think that it's harder to do some things in Kotlin than it is in Groovy. Groovy's been around a lot longer. But it's also safer because it's got that null safety built into it. So there's a lot of features there. Now, if you're thinking Scala, because that's the next natural question, right? How does it differ from Scala? The type system in Kotlin is simpler than that in Scala, but still interesting. If I can use a really bad joke, it's not a joke really, but I had a discussion with Hadi Hariri once, and I told him that to me, Kotlin was kind of Groovy for cowards. I'm so afraid of getting a null pointer exception. I never want a null or, and all that. And therefore they lock so many things down. And he laughed and he said, well, he sometimes used to think of it as Scala for dummies. That it's not nearly as complicated or as difficult as Scala, but it borrows features from both languages. So it's really more use case driven as to when you'd want to use it. If null pointer exceptions are a big part of your life, then Kotlin naturally helps get rid of the bulk of those. It's just mostly a style thing.
But Java's going to fix all our null pointer issues by making them clearer to read, right?
Exactly, right. That, by the way, if you're not aware, in Java 14, now you get null pointer exceptions with more clear errors to say where the null pointer came from. So whatever.
Okay. Another question we got is Kotlin going to support Java 11? I heard they only optimized for Java 8. And follow-on question to that is, what does it mean for Kotlin to support a version of Java?
Okay. there is a difference between optimizing the bytecodes for Java 8 and earlier than Java 8. Because earlier than Java 8, they have to take things like lambdas and turn them into anonymous inner classes, because that's all Java has at the bytecode level for 6 and 7. So once they hit 8, then they could work with the structure in 8 and above. Now, I have run Kotlin on 11, 12, 13, 14. I think I've run it on 14. I've run on everything and hadn't had any trouble. I don't know whether there are plans to optimize it for the higher levels, but I don't know that it's actually going to make that much difference either. The Kotlin I've run on Java 11 seems to be fine with all the features from Java 11. It's fast because Java 11 is fast, you know? So I don't know if they have plans to even more, you know, optimize Java 11 bytecodes. But I'd say for the time being, I think it's probably fast enough. But that's something that you'd have to ask the JetBrains people.
Okay, we've got a couple more questions.
Yeah.
There's fun and open fun. The open version can be overridden. Does
Right.
that mean a fun is public by default but cannot be overridden?
That's correct. That's exactly right. And by the way, if the function's open, the class has to be open, or you can't do that either. So it's like abstract, you know, it's the method and the class kind of thing.
Okay. Recently from the chat, can you compare Kotlin performance to other programming languages?
Yeah, the performance really comes down to the JVM performance. It's really generating bytecodes. Now, keep in mind, the biggest killer app for Kotlin is Android, and Android's operating in a very small environment, you know, limited memory, limited disk space, limited processor power environment compared to what we're used to on the server side. And they have optimized for that. So the fact that the Android people are very enthusiastic about it and use it all the time shows that the performance is at least equivalent to what they were getting out of Java, because otherwise they wouldn't want to use it there. And the bytecodes have been optimized. I mean, it really is an excellent performing language. I don't know if anybody who said, no, I can't use Kotlin because it's too slow. I mean, I don't think I've ever heard that. So I think that, again, that's not an official word, but that's my sense out of it.
Okay, I'm going to ask one more question. If this
Yeah.
is not your question and you asked a question in the chat, I missed your question, please re-ask it now. The last question that I do have on my list is mine. What feature do you wish Java would copy from Kotlin that they haven't already copied?
I really like those single function expressions. I mean, I know that's it's just a little thing, but I really like it. But as we're going to see a little bit later in the remaining part of this, that leads to something called scope functions, which will allow you to chain a series of calls together to build up a nice readable expression that does all sorts of nice stuff. So I like those single expressions. I'd like it if Java had an if expression that returned a value. I mean, now that their switch expressions return a value, I hope that's in the plan. I don't know. So those sorts of things. Ultimately, what's really going to be the big impact will be the coroutines and how those wind up being implemented in this similar feature using those fibers. Java has 25 years of backward compatibility to worry about. So they're very cautious on how they add things, and we'll wait and see how all those things work.
Okay, we got two new questions. These do not look familiar, so I didn't miss them. Does Kotlin have something that's similar to Scala's actors?
Not explicitly. Data classes can be used for that purpose because, again, they're kind of final and everything, but there's nothing that is specifically an actor type. You'd have to look at one of the libraries, and there's nothing in this. I should say there's nothing in the standard library that's analogous as far as I know. And what was the other one?
I didn't ask it yet. Does Kotlin support algebraic data types like sum and or pattern matching?
Well, what they do have, and I think somebody mentioned, there's something called sealed classes, which are like enhanced enums. You know, they're like enum types that have methods in them, but you can only have a certain type and its subclasses, and you declare all those types ahead of time, and then that's all you have. And it's very powerful there. Okay, so seal types are very nice. I just don't happen to have an example of them right at the moment exactly. Now, let me go on to a few more things, and then I'll come back in about half an hour, and we'll address some more questions. Is that okay with you?
Sounds good.
Okay, so let me get to something interesting here. Let me move on past the Lambda stuff. Again, you instantiate classes without the word new. You have to open functions and classes, and then when you override them, you use the word override. Now, notice this syntax here. Colon is used both for extends and for implements. And the way you know whether it's an extend versus an implement is the parentheses here, because this is invoking a superclass constructor. So what you put after the colon is the superclass constructor you want. So it's like calling super. And then if there was a comma and interfaces without parentheses, you'd know they were interfaces because they didn't have the parentheses. That basic idea there. All right, let me skip that. Here's the companion object. This is more of how Scala handles things that are static. The idea here is a companion object is a singleton inside of a class. So this would be a static method in Java, this instance method, which is instantiating the class. I mean, this is a factory method that's not trying to cache it or save it anywhere. It just says, if I invoke instance from the class name, see how that really is being done here, then it's basically, because that's in the companion object, it's invoking it as though it was static in the Java world. So there's the companion object. And if you have constants or other things that fit as static properties, you could put them inside the companion object, which is a singleton inside of your class. Okay, now let me give an example. Now the example I want to show is accessing a RESTful web service and turning the values into Kotlin data classes, because Kotlin data classes are ideally suited for JSON decomposition. Well, JSON serialization and deserialization. The URL class from Java has been enhanced in Kotlin to have these two extension functions. Read bytes returns a byte array, the content of the URL, and read text returns a string, and you can override the default character set or just use the default here, as they're saying. So read the URL as a string with a supplied encoding. So the example I want to demonstrate here is, let's see, this one. This is a site called opennotify.org that has open APIs from outer space. And one of the things I can do, it takes data from NASA. So let me look at this number of people in space one at the moment. And you can see how the URL has .json on it. They're doing their content negotiation right on the URL. So if I click on this, you'll see this is what you get back. So there's my URL. Let me make a copy of that. And here is what I get back. I get a one big object that inside has a number and a message, and then people is an array of inner JSON objects that combine craft and name. That's the basic idea. So this, all I want to do is do a GET request here and download this data and then convert it to data classes. Now, I already have this worked out, again, to save us a little bit of time. It's already in the GitHub repository under an Astro package. So let me show an example here. I was doing it. Yeah, the reason this one got a little complicated because I decided to do it simultaneously with coroutines. Let me show you a simpler example of it. So let me say I'll make a Kotlin file with just Astro demo on it. Okay, so what I can do is I can say, let's just put in a main function and say URL is the class from java.net. Okay, what I want is that URL at astros.json. So now I've instantiated it, and now I could call read text, and the default character set is fine for me. And in fact, what I'm going to do is I'm just going to print it. So let me do a dot out, and there, that wraps it in a print line. And you'll just see the JSON data come out immediately. See, there's the JSON data, people with the array of craft and name, craft and name, craft and name, and then here's message and number. So if all I want is the string, this was really simple, okay? Now, if I wanted to do a post, put, or delete, I'd use a library like everybody else. I think somebody in the chat mentioned the Ktor library. One of the things I like about the Ktor library is they have a part called Ktor Client, which is an excellent client library for RESTful web services. Now, the Spring people have excellent libraries for RESTful web services too. You know, Web Client is asynchronous, or REST template. They both work with Kotlin as well. But at any rate, here I'm just doing a simple GET request, so that's easy. Now, if I want to convert that into something JSON related, well, let me see. I've got this combination of craft and name, and I have a top level object. So in this Astro request here, you could see I already made a data class called Astro Result, which has the message and the number and a list of assignment. And I made assignment the name of that combination of name and craft. So these data classes are already here. And by the way, it's not unusual to put all your data classes in one file, especially if they're just their entire reason for being is the JSON serialization. Okay, so it makes it really easy to look at them all together and do your top-down or bottom-up decomposition, however you want to do it. So I'm going to use these, an assignment and an Astro result. So what I'm going to say this time is I need Google's JSON library is the one that I have in the my Gradle build file. So in fact, I already have JSON as a Java library inside here, and I could instantiate the JSON class with just putting in parentheses. Again, I don't need the word new. So then I could say from JSON, and you see how my arguments here are reader in type or string in type, except it doesn't say string, it says string bang or type bang. It's got an exclamation point at the end. What that tells you is JSON is a Java library. It's not a Kotlin library. And therefore, Kotlin can't tell if that string is nullable or not. So they report the exclamation point as saying this is a what they call platform type, meaning I don't know. It might be nullable. It might not. I can't tell from here. So the compiler can't tell. So that shows up whenever you're interacting with Java. Now, if they took some of those annotations from the Java world, like not null and nullable, they could add it in and it would make this cleaner, but they didn't. So the string says, wait a minute, you want to tell me the generic type here? No, instead, I'm going to do this. See, here is all of that string. So let me cut that out of there and I'll put it here. Okay, let's get rid of this. But of course, there's two arguments, not just the string. I also have to say what class I want to convert it into. Well, that's where that Astro result comes in. And if this was Java, I'd write .class, but it's not Java. In Kotlin, you write : class, but that's actually not the class. That's a Kotlin K class, but it has a Java property on it to give me back the Java class. Now, the reason I'm using this library is because Kotlin doesn't have a JSON decomposition library built into it. There is a library being developed called JSON serialization, but like Groovy has a JSON slurper, for example, Kotlin doesn't have one of those. This is, again, a difference between Groovy and Java or Kotlin. I imagine eventually it will, but right now it doesn't. So I'm going to use JSON because why not? So now this will go ahead and create an instance of Astro result. And in fact, I could do print that. And if I print that, what you'll see is because I used the data class, I have a built-in toString method. There's message equals success and number equals 3. And then people is this array or list in my case. And assignment has a toString method with name and craft like that. Now, you saw how I wrapped that in a print line. One of the neat things about Kotlin is they have these things called extension functions. Like there's a rather scope functions. I can add in a function called also, which would take a lambda. And the idea is to put in a lambda that takes whatever the current argument is, in this case, an Astro result, and returns nothing. So I could go print line it, for example, and that would be the exact same behavior that I saw. Say, okay, you got it, also print it. But if I'm going to do that, this in fact could be a method reference like this. And now it's using something similar to what you see in Java's method reference syntax, saying use println as a top level function that it's able to resolve. And again, one more time, you can see the values coming out of it. And it all works like that. Now, if instead of printing it, I also, whoops, sorry, I didn't mean to do that. If I say, you know what, I also want the value back, then I could say, let's introduce a local variable, which I'll call result. And there's the result, which again is of type Astro result. The also is still the same because all it does is print it. And then I could say, you know what? I know it's not null. So I'll specify the type explicitly not to be null. And now I can go ahead and destructure it and say for each name and craft in result.people, let's print out string $name aboard $craft. And the question is whether I got name and craft in the wrong order, but I think I got it. Let's see. Yeah, and now you can see there's the output of the converted result, because I still have that also there, but I can access the collection inside the Astro result and destructure it, and then therefore use the values immediately like this. So you see how how all these features kind of work together to give you something a little bit interesting in that case. Okay. Any questions that I would need to address on this at the moment? Anything come up there? Okay, I'm going to assume there's nothing major to deal with right now, and let me go on then. Okay, now again, I use that because read text is an extension function added to the familiar URL, and it does a GET request automatically.
Can you hear me, Ken?
Oh, sorry, now I can. Yes, Gene, what did you say? I heard you for a second. I don't hear you anymore. All right. Oh, go ahead. Let's try again.
That was a tremendous amount of lag.
Yes.
Can you hear me live?
Now I do, yes. Oh, well. All right. I'm sorry that Gene's delayed. I think mine's still working okay. Chat's fine. I'm seeing that can you override hash code and equals? Yes, you can. And data classes do it automatically. But in fact, if you want to see an awesome example of an override of equals, for example, take a look at a class called Kotlin version. And I think I have a great example of Kotlin version. Let's see, where do I have it in here? Kotlin version. In my Kotlin version tests here, and if I go to the class itself, oops, here. Okay, this is a class that is part of Kotlin. It's in a file called kotlinversion.kt, and it has properties major, minor, and patch. Like the current version of Kotlin is 1.3.71. Okay, notice it implements the comparable interface. There's the generic type. There's comparable. So here we see a constructor that's an additional one. See, this is the primary constructor defined at the top. This would be a secondary constructor, an additional one that delegates to this with 3 values on it. So isn't that interesting? So there's a secondary constructor. This says version is a version of this. Well, version of is the function right below. It says take major, minor, and patch. And what it does is it does a bit shift to shift the major version by 16 bits and the minor version by 8 bits in a patch, and it makes an integer out of that. So this version is basically an int, as you can see, that's made from the bit shifts. But here's the good part. Here's the equals method. Returns a Boolean. It takes as an argument an any, nullable any. So they start with triple equals. Now the triple equals is important here because double equals would invoke the equals function, and then I'd be in an infinite loop. See, that wouldn't work because Kotlin uses operator overloading, and double equals invokes the equals method. Triple equals is reference equality. Are these two references pointing to the same object? Well, then yes, we're the same. Then here's where it gets interesting. As is Kotlin's mechanism to do casting. And as question mark says, if other is not null, cast it to be of type Kotlin version. But if it isn't a Kotlin version, then it's going to return a null, which is why they threw an Elvis operator here, which says, look, if it's not a Kotlin version, then we're not equal, and just return false. And you're immediately out. So they say if this is a Kotlin version, then cast it That's the other version. And then this dot version here will invoke that get version function and compare it to the current get version function. And that's how they implemented equals method. And I just think that's amazing. I mean, it's so short, and yet there's so much power once you've been through it, that I actually put a blog post about that just because I thought it was cool, you know, and I talk about that in the book as well. Now, notice the hash code is just that version calculation, just a sign there, and the compare to is subtracting those two versions. So this is a great example of what is basically a simple class with some attributes, and how you could have overloaded constructors and private functions and equals and toString and hash code and even additional functions like is at least and stuff like that. And look inside the companion object, there's the max component value. If you check is at least, and they look at the major, minor, and patch values, then if it's greater than, actually, this is not the one I wanted to see. It's in the constructor, I think, that they say require major is between 0 and max component value and minor and patch. So that this is the maximum value of major and minor and patch. And the current field, they have a public current field, is 1.3. In this particular code, 70. Now, see this little annotation here? That says now this field is exposed to Java as well. Sometimes it doesn't show up in companion objects. This wouldn't show up as a static field in Java unless we add the annotation. So now this could be called from the Java side as in addition to the Kotlin side. So I love this example. And again, I break a lot of that down in my blog. If you're interested in seeing it, it's also in the book, but the blog's free. So if you want to see that. So again, it's just an interesting little example. Now, let me go back to what else is here. Looking at some of the other questions in the chat, I don't see anything. Oh, the running from Java. If you are running from Java, then you need to know the name of the generated class. So for example here, as a trivial example, in my Java section, I have, not the one I want to see. Let me just say it this way. Here's my Astro request, and I have this function called URL using JSON. Actually, see, this is the same code I wrote before, but I'm doing it as a coroutine using a dispatcher, IO dispatcher, so that I'm off the main thread, if you will. And then here was Ktor supplies an HTTP client. I install the JSON feature, and then I could just use Astro result as the generic type, and that works automatically. I was going to call this directly from Java. What you'd have to do is Java would say, well, what's the name of the class this is inside? Well, the name of the file is astrorequest.kt. So from Java's point of view, the name of this file would be astrorequest.kt.ktor client. See, it would invoke this as a static method in the generated class, and the generated class would be the name of the file with a KT at the end appended to it. Now you have annotations where you could change that, but that's the basic idea. All right, now I've got a couple other kind of cool examples, and then I'll hang out if you have any additional questions. But at any rate, there's that Astro request, and I've got a test for it as well in case you're curious. Question, when did Google decide to move to Kotlin? Be careful. Google does a million things at once. You know, they have a whole bunch of groups that are all kind of competing with each other, and then they wait to see what sticks. And that's why sometimes Google just says, yeah, we're not doing this anymore. And you're like, wait a minute, I've invested, you know? Well, Google's move to Kotlin was when they adopted Kotlin for Android. Now, what I'm not sure about is whether that was a recognition that the field was already moving to Kotlin, or whether they decided this was a way to get out from under the JVM-based lawsuits from Oracle. You know, it's an interesting question. But at any rate, this all occurred about 2016, and then I think became official around 2017 or 18 when they officially endorsed it as the language there. Everything else Google does works with whatever language they specify. Okay, now, if you're a Java person, you're familiar with collections and streams. Kotlin doesn't use streams the same way that Java does. Instead, they have sequences. But if you understand Java streams, a Kotlin sequence is a Java stream. It's basically the same thing. It passes each value through the entire pipeline one at a time. It doesn't do anything until you have a terminal expression. It has all the functions like map and filter that you're expecting, you know, reduce functions as well. For reduce, they have both fold and reduce. One of them takes 2 arguments, one only takes 1. It's kind of funny because in Java, they have the reduce method that either takes a binary operator alone or an initial value, which is really what you call the identity value for the binary operator and a binary operator. But in Kotlin, they named one of those fold and the other one reduce. And I think they probably did it because I think that's how Scala does it. And again, it's borrowing these things from the other languages. I talked to you about the pair class already to show you that. Here's some neat little miscellaneous features. For example, they have this nice little method called measure time millis or measure time micros or measure nanotime. Notice again, the argument is a lambda. They call it block, but it's a lambda that takes no arguments and returns unit, but the overall function returns a long. So to show you a trivial example of that, let me go to measure time. And now this one, I actually used Java streams inside there. So just to show you that it's perfectly fine to work with java.util.stream.instream unless you're committed to multi-platform, right? I mean, if you're committed to multi-platform, then I don't think there's a JavaScript equivalent. But I'm just operating on the JVM, and it means the whole Java library is available to me. So what I did is I have a function called double it that takes an int and returns an int. And the only thing I'm doing inside the braces other than returning the value is I'm sleeping for 100 milliseconds and printing out which thread I'm on. Now, another interesting thing here is if you're familiar with sleep method from Java, it throws an interrupted exception, which is a checked exception. All exceptions in Kotlin are unchecked. Okay, so you don't need to do try catch blocks, although you can, pardon me. And the try-catch block has the same basic form as it does in Java. So this is going to sleep for 100 milliseconds and then double X on whatever thread we're on and return it. So down here, I print out this machine has runtime.getRuntime.available processors to find out how many processors I have. And now I'm going to do measure time milliseconds by making an int stream of size 8. So 1 through 8. I'm going to map each of those integers to the double it function up here. So map them to their doubles and then sum them. And I'm using an int stream because int stream has a sum method. So this is really straight Java, except for the fact that I'm invoking a Kotlin function here. You know what? I don't know why I didn't write it as a function reference. I guess I wasn't thinking about it. So at any rate, I'll do it as a function reference. Then I say, okay, now this is a sequential stream, right? Because all streams in Java are sequential by default. But that was so much fun. Let me throw in a parallel so that I could do the same thing, but now using a parallel stream. And because I'm using this measure time millis function, I can make this variable a var type and overwrite it. And by the way, remember I said there's this subtle pressure not to do this. You see how this var type has an underline on it? In IntelliJ IDEA, the time has an underline on it because it's a var type, because it's variable. It could be modified. And that's its way of catching your eye and saying, wouldn't you rather do that as a, as a val type or something? At any rate, I'm just going to execute this and let me show you that in fact parallel streams work here. And my machine is one of those new Macs that has, it says 16, but it's really 8 processors because of virtualization. It reports 16. But you could see, remember my doublet is saying what thread I'm on. So in this one, which is going from 1 to 8, I'm on the main thread for each of those 8 doublings. And it takes a little over 800 milliseconds because I have 100 millisecond sleep each time. Whereas this time I'm in parallel and I have enough processors to handle 8 values. So in fact, I get the fork, join pool, common pool with all those different workers, and it only took a little over 100 milliseconds. So I set it up. I mean, it's a rig demo. You know, I wanted to see a benefit here, but I'm basically using Java parallel streams. I didn't bother with a suspend function or anything like that. I mostly wanted to say, here's an excuse to use measure time millis. And the question is, in measure time millis, how does this work? Well, let me go inside it. And it says, okay, inline function, measure time milliseconds. Now, the inline part means that when you saw measure time millis in the usage, it actually takes everything in the braces here and replaces what we saw with that. I mean, it's inlining the function, if you will. This is another reason the Android people like it, because in Android apps, you have a limit on the number of methods you could have in the overall app. So this says take a block, which is a lambda with no arguments, returns a unit. And inside here, they say, let's just call system.currentTime milliseconds and then invoke the block and then call it again and subtract the start. I mean, it's as brute force as you can imagine, you know? So this isn't a great profiling mechanism, but it's in the standard library. It's really easy to use right in there. And here, by the way, is how they could change the name of the generated class to be timing KT, although I don't know why they bothered. That is the default. The name of this file is timing.kt. The name of the generated class be timing KT anyway, but so be it. You could specify a different name. So there, just kind of a neat little feature, again, that works with many of these others. Okay, a couple other neat ones. I think I'll skip this for the moment. Here, this actually uses a Ktor example, although I'm not going to execute it. But one of the things you could do is use this scope function called apply. And what apply does is it says, once you have an object, also do the following. So it's the stuff like this would normally go in a constructor if you could do that, or it would be in some kind of initialization method. You know, Java has always struggled with that. They have constructors to create objects, but if you then need to wait until it's instantiated before you could do something, like with EJBs or even with Spring Beans, you need to wait until it's fully registered as a Spring Bean before you could do something with it. Well, Kotlin has added this apply function that takes a closure, well, a lambda, and says, okay, after the object's been instantiated, then go ahead and do this. Now, what is this one doing? The Ktor API has a function called embedded server, and you say what kind of server, Netty or Tomcat, or I think Undertow is also supported. You could specify what port you want if it's not the default, and you could say, what am I deploying to it? And that's the current module in their example. This is taken right from their homepage. And you could say, all right, once I've created the server, start it up. And that's a perfect example of an apply function. And the result is this whole thing is one long sequence of calls. See, it's not that you can't do this without the apply function. You just have to make a variable and then invoke apply on it, or rather invoke start on it. But this basically makes the chained call so it already is configured and started up in one long call like that. Here's the let function, which does something interesting also. This one I actually have in the code. I want to write out, I want to take a string as an argument, and I want to print out either the string, or if it happens to be empty, I'll print the word empty, but I want to make a distinction between empty and blank. Like if all it has is white space in it, or if it has some tabs, but no actual characters, I want to print the word blank. So the problem is I also want to make this nullable, because so I'd like to, I can't invoke is empty or is blank on a nullable string. I mean, if it's null, obviously that's a null pointer exception. I'm saying if it's neither empty nor blank, I want to capitalize it for some weird reason. What do? Well, on the string, I could say Elvis here. Well, that's not Elvis. Sorry, that's the safe call. Are you not null? Then let's do the following block. It's called the let function. This is another scope function that basically says, here's a whole bunch of stuff I want to do on it, but only if I say it's okay. So I'll say, if it's not null, then let's do this. If it's empty, we'll print empty. If it's blank, we'll print blank, else we'll capitalize it. But if it is null, we jump down to Elvis here and just return the word null. See, so the context is the argument, is the it variable, the string itself. And this combination of let with Elvis is very popular. And I have that actual code here. So that's the process string test that I was just trying to show you here. Oh, the functions over here. So here's process nullable string or process string. So this one doesn't require the extra stuff because I declared it without the question mark. This one does have it. So I put in the let with the Elvis, and the tests are just basically run it through all its different options here. Just kind of a neat little demo of the sorts of things you could do. And notice the result is everything is a single function now. You know, I don't need the braces because I wrote it as a single extended function. Okay. Any other interesting ones? Because I want to come up with like a couple of ending ones and stop, and then I can take questions again. There's that also function I was telling you about. I had a friend tweet that also print line was his debugger, basically. You know, so it's basically whatever I have, print it and go on. If you're thinking Java streams, the equivalent to this in a Java stream would be the peek method, P-E-E-K, which takes a consumer as an argument. So it's saying, okay, go ahead and consume it, but I'm going to return the value anyway. And that's what also is doing. It says, do a side effect and then go on. Let me skip the sorting. Delegates are really cool. This is another thing built into Kotlin. This is a delegate. T also is an interesting idea. Yeah, it's somewhat similar to that, except I think it's more the combination of let and Elvis is more of a T operator, the way you're describing it. But I'd have to listen to that. Oh, we need to do the raffle too. So, okay, I'll just go a couple other examples and then I'll stop. So first of all here, by indicates we're going to use a delegate. And a delegate is another function in another class. So this is a built-in delegate as part of the Kotlin library called lazy. Lazy takes a block, and the way lazy works is that the first time you access this variable, it invokes the lazy block, and whatever value that returns, that's the value of ultimate answer here. And then each subsequent time, it just returns that value. So this is your lazy initialization mechanism. I could say, I don't have a value for this yet. I'll wait, and when somebody accesses it, then I'll print out, hey, I'm computing it now. And of course, the ultimate answer is 42. So then after that, it'll just return it immediately, if you will. I could build in a sleep or whatever. There's also an observable one where I could see values being changed, or vetoable where I could say, you know what, I don't want only values that are positive or allowed to change. You know, again, I'm just kind of skimming through things and saying there's examples in the source code. You're welcome to take a look. There's a function, believe it or not, called to do. And it's, I mean, again, only an IDE manufacturer would come up with this, right? The function called to do is an inline function that returns nothing. Basically, what it does is it throws an exception. Well, it throws an error, actually, a not implemented error, so that you can put code in your IDE that is invoking the to-do function. And if you execute it, it throws an exception. And of course, IntelliJ has a little window to find all the to-dos. So kind of cute. And that would lead us into a discussion of nothing if we want to go to it. Instead, I talked about that Kotlin version as a neat one. So you got to see that. Let me skip again on nothing. Let me tell you about this, and I'll just show you the answers rather than take the time to do it. But this one's kind of fun. Oh, the much ado about nothing is the discussion about the nothing class. So if you have questions about it, let me know. I've got a whole discussion in there, but I don't want to take the time to do it right now. It's one of those things that's guaranteed to confuse Java developers. Okay, but it makes sense once you've seen the discussion. Graal is a virtual machine being provided by Oracle now. And its biggest feature is that it's cross-language compatible. But I don't care about the cross-language capability. What I care about is that there's a tool that you can use with Graal called Native Image. So here I'm using SDKman. The SDKman at sdkman.io is a package manager that's used to install products, including Java. Well, I installed a Java version that comes from Graal, and I'm going to use it. And then from that, I'm installing this native image tool. Now, this Antarctica.kt is actually, let me show it to you. I've got it right here. Clear this. So cat Antarctica KT. And this is basically a function with a main method in it, you know, that is using a regular expression to find all the time zones in Antarctica and filter them by, again, find all the time zones, filter them by being in Antarctica, then sort them by their offset to GMT, and I could print out. And the most important thing I'm trying to find out here is whether they're on daylight savings time or not. And the real joke is about the South Pole. So first of all, if I say Kotlin C, I want to compile this, and technically I should say -JVM. That's the one I'm on. Antarctica.kt here. Then that would compile it. And then if I look at that directory, now I have this class. I could say Kotlin Antarctica KT and then run it. And you see, believe it or not, the South Pole is currently on daylight savings time, which just blows my mind. But at any rate, there's my little script here. But you saw it took a moment to start up. And part of that startup time was the startup of the JVM. Okay, now you can actually write a Kotlin script, but even that, all the difference there is it doesn't have the main function and it's got the rest of the code. But if you go through this process of saying first compile it, and then I execute it just to show it works, and then I'll say include the runtime and make a jar out of it, then I could run the native image tool. And what that does is that produces this function called Antarctica as an executable. And if you see me just run that, bang, that ran right away. In fact, the timings, those were the time zones in Antarctica, by the way, you know, the scary part. But, oh, don't I have the statistics somewhere? Oh, yeah, they're right here. Sorry. When I run the regular one, it takes this amount of time. Or with the jar file, I could run it from Java because I included the runtime. But this one, the script, took almost no time at all because it doesn't have the startup time of the JVM or the memory requirements either. So there you go. Just I wanted to show that this is possible, and it's in the slides if you want to see it. And I think that's all I want to show basically there. So let me go back and say, do we have questions, comments, words of wisdom?
I can. I think we're going to do the raffle before.
Yeah. Okay. So let's go ahead and do the raffle.
So let's start the raffle. So we have 3 books to raffle. Jean, how many users do we have? I think Jean has no sound, but she can type. 123. I don't know if that's the number of registered people or online people, Frank. Online? All right. So, 55. All right, Ken, you're the speaker. Choose 3 numbers between 1 and 55.
Are you serious?
Yes.
Oh, wait a minute. Actually, you know what? I can do this from the command line. Kotlin C without an argument is the Kotlin REPL. And if I go random dot and hit tab, I think actually, before I do that, wait a minute. See, here's random has a next int function, but you can actually put in a limit here up to how many. So you said random, wait, did I have to instantiate it? No. Okay, random dot next int out of how many would you say 120? How many?
No, 55. 55 that are online.
Really? That's all?
Yeah.
Doesn't seem fair.
Yeah.
Oops. Sorry, it's a package thing. Kotlin.random. 23.
23.
Okay, keep doing it. 2 more times.
Yes. 3 books.
9 and 8.
All right, Jean. 23, 9, and 8. So I think Jean can.
Yes, it's only pseudo random. it's a pseudo uniformly distributed. No, never mind.
Yeah. So Jean is gonna email you. Again, maybe you can put the picture of your book.
Oh, yeah. Okay, so here is a couple of things. Oh, I know I should bring up. I should bring up the shared doc.
Sure.
Where did I put the shared doc? That ought to confuse everybody. Let's see. Oh, here it is. So this was the shared doc. Again, this was the URL for the shared doc. Let me copy and paste that for anybody who came a little bit later.
Ken, 8 and 9 are myself and Jean. So get 2 more, please.
it says, can you draw 2 more winners? You know, I tried to paste that thing again. And
I don't know when you'll hear this, but we need more winners.
Yeah,
okay.
we did. We just heard it.
Oops. All right, wait a minute. That's driving me crazy. So let's do there. Okay.
All right.
13 and 21.
13, 21.
I think I could have done, well, no, there's various overloads on the random class. And by the way, that's another interesting class to look at because this is in the companion object. That's how it's a static method, you know?
Charles Herman, the second winner. When I win in a raffle, I cannot take the prize. That's not fair.
Oops. I'm trying to get back to, yeah, here. Okay.
That's fine. I'm going to buy myself and you need to sign it.
Well, I'd be happy to if we could figure out a way. This is the other thing is I'm running some of these online courses from No Fluff, Just Stuff. One of them is on Kotlin. One of them is on Java. One's on Groovy. These are all at the No Fluff, Just Stuff site, No Fluff, Just Stuff. And they're doing these virtual workshops starting next week, actually, with machine learning platforms and Angular and everything. So mine are here, a Java best practices, a Kotlin basics, and Groovy for Java developers. So perfect. I know the No Fluff people wouldn't be happy if I didn't say that. So there it is.
All right, perfect. Gene, do you have any questions that we need to answer?
Okay.
Any new questions? I think not. I think Justin, Chandra, they were answering everything. Thank you, Justin, thank you, Chandra. Great to have you guys aboard. So I guess that's it. If you don't have any more questions, Ken, I would like to thank you very much for your presence. Very happy to have you here. Please stay tuned. Follow NYJavaSIG and Twitter, Facebook. We have our YouTube channel as well, but mostly on Twitter where we are more active. We're going to have more events. Stay tuned. We should have 1 or 2 more events in April. So please stay tuned. Thank you very much for joining us. It's a pleasure. Ken, once again, thank you very much. Thank you for all the NYJavaSIG for hosting the event.
Oh, very happy to be here. I always like it. I mean, this is, the only sad thing is I didn't get to visit New York out of it, you know, but so be it, you know, and just, I really had a good time. So thank you very much. And everything that I did is in the GitHub repository. So that's available too. All the links are in here. And if you can't get something, you can't find something, just send me an email and I'll reply there. And thanks again, as they say in the chat, to the Eclipse Foundation as well for providing the sharing. Right.
Mm-hmm. Perfect. All right. Thank you. Have a good night.
Take care.